S3 Vector Search is a new service from AWS. It allows you to add vector search and semantic search to an app that's already on top of AWS without leaving the AWS ecosystem. It's incredibly cheap because it's all billed based upon usage rather than flat fee. It's also very easy to set up. Probably a lot of companies that rely on vector search as their selling point are going to have a hard time now. The core point of vector search is to allow your users to search based upon the concept rather than the exact text match of something. Let's say you're IMDb and you have a database of movies. Let's say you've got 3 movies, Batman, Superman, and Spider-Man. In our front end, we want a user to be able to put in a search query that is not the exact name of the movie, but something like dark, gritty movie. We want it to hit the back end and come back with search results that would have Batman at the top. On the other hand, if we put in a query like movie about arachnids, we'd want Spider-Man to come back at the top. We can use S3 vector search to achieve this. I'm going to walk through an entire TypeScript application end to end and show everything you need to do to set this up. First, let's say we're IMDb. We need to ingest all of our existing data into S3 vector search service. There's a few steps to this. Vector search relies on comparing vector embeddings between both our database items and the search query. A vector embedding is basically a list of numbers that connotes the concepts that are inside of the string that we've encoded. So let's say we've got our movie titles and then our search term. Then we need an embedding service which turns all of this stuff into vectors. In our case, we're going to use AWS's Bedrock and Titan model series. So first we need to plug all of our database data in. This will get back a bunch of vectors, which we'll put into our vector database. Under the hood, vectors just look like a string of numbers. Then when a user does a search, we have to encode that search query into a vector. We'll put the search query back into the vector database, and the vector database will return the full list of vectors out of these ordered by similarity. It'll be able to see that the vector for gritty dark is very similar to the vector for Batman, and so it knows to return Batman at the top of the results list. So our very simple app is going to have 3 main components. We're going to have an ingestion script which will take our data and put it into the vector database. We'll have a React front end as part of our Next.js app. The React front end will take a search query and then hit the backend. And we'll have a backend route which takes that query, turns it into a vector, runs it against the vector database, and then returns the ordered list of results back to the front end for the front end to show in an ordered way to the user. I want to show you end to end how you can use the S3 vector search service. I'm going to build a full Next.js app with front end, back end, and ingestion. So first I want to show the ingestion pipeline. This is a very simple example. We want to create a service that allows searching 3 movies. So we've got Star Wars, Jurassic Park, and Finding Nemo. The ingestion service needs to end up with a bunch of vectors stored in Amazon S3. To do this, first we call this script ingest.ts. We first need to loop through these texts and generate a bunch of embeddings. We do this by calling the Amazon Bedrock SDK for TypeScript. It's pretty straightforward. We just call invoke model command. It's incredibly cheap. These vector embedding models are cheap nowadays. This Titan model is not the best model. It also kind of locks you into Titan to some extent because you've got to regenerate all the vectors if you want to move off Titan, but it's not the worst thing in the world to use. It's incredibly easy to use. Once we've got the vectors, we call put vectors command, which is basically an S3 method to put a bunch of vectors into S3. You can see you've got to put the vector embedding inside of this data. We've also put a bunch of metadata for genre, the actual source text. The value of this is just that it allows that metadata to be retrieved when the vectors get retrieved from S3. Next, I want to show how we actually use this vector embedding. Another important piece is we need to do a bunch of setup before we get started. I've got this other script called setup index. First, we have to create a bucket. You probably want to do this with Terraform or manually in the AWS console, but I've used the SDK for simplicity. I've created this bucket called media embeddings. I've also created a vector index on this vector bucket with dimension 1024. You need this to match up with whatever the dimensionality is of the model you've picked in the ingest step. So you can see this Titan model has 1024 dimensions. You can find that in the AWS documentation. Pick float 32. This is just standard. Distance metric cosine, also completely standard. You don't really need to worry about this. This is just the industry standard. It just means look at the 2 vectors see if they're similar or not. Now, to make use of these vector embeddings, we need to have an API set up that the front end can hit. The API needs to take care of generating a vector on the fly for the query that the users put in, running it against the vector S3 store, and finally returning the results. So this is a standard Next.js API route, but there's nothing special about Next.js in here. It grabs the query, the exact same invoke model, grabbing the vector embedding. It grabs that embedding and it puts it into the query vectors command, which is an S3 command to find the most similar vectors in the S3 vector store. It does top K, which just says get the 10 most similar based upon cosine. Finally, we return the results. And you can see we've got the metadata here, we've got the key here. The final piece of all of this is we need to set up the front end to allow the user to put in the query to get back the results. This is a very simple React component. I vibe coded this whole thing. You can see it just is a very simple page that allows the user to put stuff into a form, into an input. When they click submit, it'll call our search endpoint in Next.js, grab back the results, set results like React state reactivity. Those results will then show up here. So now I'm going to show you through the actual app that I've got running on my local. You can see it's a very simple app. So first I want to test, can I get results relevant to like Finding Nemo at the top? So when I think Finding Nemo, I might think turtle. If I search this, what do I get? Finding Nemo is at the top of the results. If I search, laser, I want to see Star Wars. Well, that's not good. Very interesting. Let's do something easier. Okay, so that's worked. So vector search is actually not that great a technique, but it is just currently the state of the art. It's kind of like, I think very often when a technique is just good enough to fill a gap, it becomes widespread. That's what's happened with vector search. Vector search is not that good. A lot of the time you want to use just an LLM re-ranking model. It's a much more effective strategy because, it can't handle simple stuff like laser. But if I put stuff like vegetarian shark in, good, that's what we want. That's terrible. That's really bad performance. It's possible this AWS model is not that good. So the good thing about the AWS vector store is we can actually use any model embedding we want. We can use better performing models from OpenAI if we want to. There's no real problem there. That's a real easy one to get right, is just Dinosaur.